Hello dear students, welcome to this video number 3 on unit number 1, impact of jets, impulse momentum principle. So in this video number 3 we discuss the impulse momentum principle. So before starting with that, we should know what is the impact phenomenon and what are the free jets. So the jet of water discharging from a nozzle in the atmosphere is called as a free jet. Okay, the jet produced by the nozzle in an atmosphere is called a free jet, and it has a constant pressure throughout the jet. Preferably the jet has atmospheric pressure inside the jet, which is produced freely in the atmosphere, known as free jet. So pressure is constant and it is atmospheric pressure. The jet coming out of the nozzle has certain amount of kinetic energy, and when this jet strikes a vane or a blade, or we can say a flat or a curved plate, what happens is the jet exerts a force on the plate. Why? Because the jet has a kinetic energy produced by the nozzle. This impressed force by the jet on the surface is known as impact of the jet. The phenomenon is impact of the jet, which is designated as hydrodynamic force. This force is known as hydrodynamic force. Okay, force exerted by the jet on the surface. This force is due to fluid motion because of dynamics of the fluid, which always involves change in momentum. Okay, as the jet strikes the surface plate, there will be a change of momentum. It can be obtained from the impulse momentum principle or the Newton's second law of motion. So the force exerted by the jet can be obtained from impulse momentum principle. It is nothing but equation obtained by modifying Newton's second law of motion. Okay. Now coming to the point of impulse momentum principle. The impulse momentum equation is one of the basic tools which is used in conjunction with continuity and Bernoulli's equation, and used for the solution of real world fluid flow problems. So impulse momentum equation is similar to continuity equation and Bernoulli's equation. Okay, so these three are used in the solution of fluid flow problems. The momentum equation is based on impulse momentum equation is based on law of conservation of momentum or momentum principle. Okay, now we will see the statement of law of conservation of momentum. The net force acting on a fluid mass is equal to change in momentum of flow as per unit time in that direction. The net force acting on a fluid mass is equal to the change in momentum of flow per unit time in that direction. Okay. So as per Newton's second law of motion, F force is equal to mass into acceleration, where m is the mass of the fluid, F is the force acting on the fluid, and a is the acceleration acting in the same direction as of the external force. So the direction of acceleration and force should be same. So but acceleration is equal to a is equal to dv upon dt. So putting in that equation, so F force is equal to m dV by dt. A is equal to dV by dt. So this is equal to, force is equal to, taking m inside the differential, so dmv by dt. M is taken inside the differential since it is constant. Okay. So this above equation, F is equal to dmv by dt, is known as momentum principle equation. It can also be written as F into dt is equal to dmv, differential into bracket mv term. Here the term f dt is known as impulse for a short time duration dt. F dt is known as impulse, and dmv is the resulting change of momentum because of the applied impulse. mv is known as momentum. It is a product of mass into velocity of the substance. Okay, so dmv means change of momentum. The equation, and this equation is known as impulse momentum equation. This is known as, okay, impulse momentum equation. The statement of this equation is what? The statement says the impulse of a force F acting on a fluid mass m in a short interval of time dt is equal to the change of momentum in the direction of the force. Okay, it's very important to understand this. The impulse of a force acting on a fluid mass of m in a short time duration, suppose dt, is equal to the change of momentum of the fluid in that direction. Okay, the impulse momentum equations are often called simply as momentum equations, known as famous momentum equations. Further, if v1 and v2 represent average velocities at two sections of a fluid stream, and suppose t denotes the time interval, then the same equation of a force F is equal to, it can be written as m dv by dt, m is constant, and this can be written as m upon t time into bracket dv. dv means final velocity minus initial velocity, so v2 minus v1. Therefore f can be written as m by t as a m dot, okay, into bracket v2 minus v1, where m dot means m upon t. It means mass per unit time, mass flow rate in meter per second. So this is also equal to mass flow rate is rho into q into bracket mass flow rate is rho into q, okay, density into volume flow rate. So F is equal to rho q into bracket v2 minus v1. The above equation represents the force exerted by the body on the fluid. Okay, it's very important. This equation gives you F equal to rho q or m dot into v2 minus v1. This is the equation that represents force exerted by the body on the fluid, that results in changing the velocity of the fluid, or we can say momentum of the fluid, changing v2 minus v1 in the velocity of the fluid. Now by Newton's third law, action and reaction are equal and opposite. Thus the force exerted by the fluid on the body can be written as F is equal to minus sign rho Q into V2 minus V1. This is the force exerted by the fluid on the body, and this is of our use. So force is equal to mass flow rate into bracket V1 minus V2, where V1 is initial velocity of the jet, V2 is final velocity of the jet. Force by the fluid, we can write in statement, that is like something, force by the fluid exerted by the fluid can be written as mass flow rate of the fluid into bracket initial velocity V1 minus final velocity V2. Okay, the above equation is a vector equation where maximum formulas, the above equation is a vector equation where force and velocities are in the same directions. So here we have vector equation. Okay, on left hand side there is a force, it is a vector quantity. On right hand side mass flow rate is scalar into difference of the velocities beam. So it is rho Q into V1 minus V2. So remember this end formula for impulse momentum principle. It is the force applied by the fluid on the surface. Okay, that is given by mass flow rate into initial velocity of fluid V1 minus final velocity of fluid V2. Okay, so this completes our topic 1, that is impact of free jets and impulse momentum principle. Okay, see you, bye.